How's it, guys? Welcome back to my channel. This is Ivan, and I'm busy testing this drive. You can see the cover is broken here, so it's an oldish drive. So I'm just testing it, and I thought, well, in my last video 6E, I said let's start with RX485 communication between a PLC and a VSD. But as I was testing this drive, or started testing this drive, I thought, okay, well, let's first do control without a PLC. So meaning we give it a start forward, start reverse, and 3 preset speeds, RL, RM, and RH, which is run low, run medium, and run high. Let's first do that. It's just a hardwired stop start, 3-wire hardwired stop start with 3 preset speeds through a selector switch and a stop and a start button. Let's first switch on this drive. Okay, let's first go and put this in PU mode. It's an external mode. Let's go and clear all the parameters. Let's just do that. Okay, parameter clear is done. Let's do an all clear as well. Okay, all clear is done. Okay, let's go to parameter 0. Okay, let's go to parameter 9. So that's 9 amps. So yeah, this is a 3.7 kilowatt VSD, and that is a 0.37 kilowatt motor, so it's pretty oversized for the motor. Okay, let's go set up the amps. This is a 400 volt star 220 delta motor, but we're going 400 volt here, 3-phase. So I'm gonna set the parameter 9 to 1.37 amps, because that's the motor requirements on 400 volt star. So let's do that. 1.37 amps. Okay, then what we're going to do, we're going to set the base voltage. So this is the base voltage that I want out of the drive when it's at 50 hertz. So the motor is rated for 400 volts, 50 hertz in star. Well, it's got a few ratings, but we're gonna go 400 volts at 50 hertz. That's the base voltage at 50 hertz. So okay, let's see what this motor does. Let's check the amps. It's 1.18 amps. The drive is giving me exactly 400 volts out, and it's 50 hertz. 1.18 amps, 400 volts, 50 hertz. Okay, let's stop it. Okay, what I want to do, just to make the motor a little bit more quiet, so I want to go change parameter 72. This is your PWM setting, pulse width modulation. So it basically, the sine wave that comes out of the drive, the sine wave, This basically makes the pulses in that sine wave a little bit smaller. Now they do warn you that you can create a bit of I think it's EMF in around, well, yeah, around in your cable and in the system, so you got to be careful with that. But okay, we're going to, I think let's make it 7. Okay, and let's just watch the amps, because they do warn you the amps will also change when you do that. But there's no load on here, so let's see what it does. Oh, it's much quieter, 1.17 amps. So let's quickly stop it. I can't remember what's the maximum setting that I can set that at. I think it's 10. So let's make it 10. Let's just watch that amps. Okay, there's back anyways to 1.18, but it's much quieter though. So we don't have such a noisy motor. I think I'm going to leave it like that, so that when I do the stop-start section, then you can hear what I'm saying and we can have a look at it. Okay, so let's jump to the next section, the wiring. So one thing you have to be always careful of when before you start wiring a VSD is the charge lamp over there. That indicates that the DC bus is still charged. So yeah, if that charge lamp is still on, I would suggest giving it some time to discharge the DC bus, the capacitors, and yeah, it takes about, give it about 10 minutes, and then you should be safe to do the wiring. But yeah, if that charge lamp is on, just be careful, and yeah, just don't get shocked. It is a very high voltage. It's DC voltage, and on this 400 volt drive, I think I measured it's about 590 volts DC, so it's quite a high voltage. And I think on 200 volt drives it sits at about over 300 volt DCs, about 320 or so. Okay, so just keep that in mind. So now we've wired from we start with PC, that's our 24 volt DC supply, and then we go to our stop button first. So I've got a stop button, start reverse, start forward. I've got a 3-position selector switch, but the middle position is always off. And then I've got a lamp, because I'm going to also wire a alarm output if the drive trips, to display on a lamp. So we start with PC, our 24 volt DC supply, and then we go to our normally closed contact on our stop button. Okay, now we're gonna wire the next wire. So the next wire I take from my normally closed, the same as I supply my PC, to my normally closed on the one side, and then from that same side I go back to the VSD onto my common of my relay. So that's just to supply my relay common, the alarm output. And yeah, okay, so let's do the next wire. So the next wire I supply from the other side of my normally closed contact of my stop button to the normally open contact of my start reverse button, and then we're going to supply a wire from the same side to my start forward button. So that's just so that if we press the stop button, that it cuts off the supply to my start buttons. So now from the same side of that, normally open off my start reverse, we supply my start forward button, and from there we're going to supply the selector switch. So let's do that. So now from my start forward button, we go to start supplying my selector switch. And now we're going to supply all this. We're going to supply I think this is going to be run low, we're going to supply run high, and then we're going to supply run medium. And that's where a little bit of a tricky part, but not really, it's just the interlocking, so that when the switch is in off position we have the RM signal. But yeah, we're going to see that now. Okay, so now I've come from my start forward button here, and I've supplied my run low, then I supply my run high, and then we're going to supply from here to my normally closed contacts, which I've got 2 of, for my run medium. So it only means that if I'm in run high, run medium can't run. If I go over to run low, run medium can't run. But if I'm in the middle position, because this selector switch is in the middle position, it's off, then run medium will come on. But because I supply through my stop button, if I stop everything, this supply will be cut off. I'll still get a signal through to the preset speeds, but I won't have a start forward or a start reverse signal, so the drive won't run. And then from the supply of where I supply from run low to run high to run medium, we're going to take that supply back to the drive to a stop terminal, which is going to be our self-holding input to tell the drive that you're using the 3-wire stop start. And that is the bridge piece from my run high to my run medium speed. Obviously the supply that's going to supply that contact is going to come through this normally closed contact, but now we're going to take a wire from this supply and go back to the stop terminal. Okay, so let's do that. Okay, so now I've taken a wire from this supply basically, because remember we come from 24 volt DC from the drive. We go to our stop, then we go back to our C1 for the alarm output, but then through the stop button we supply the start reverse, start forward. We come back, we supply RL, RH, RM, and then we go back to the drive to go to the stop terminal. So the only thing that's going to cut off the stop terminal is going to be my stop button. It will also cut off the start forward and start reverse signals, and that's how the drive will know whether it should start or stop. It's all going to depend on my stop button. So okay, now we're going to wire in STR from this button and STF from that button. Okay, now I've wired my start forward from this button to start forward over there, and then I've wired from start reverse, I've gone to STR on the drive. Okay, now we're gonna complete, so that's basically our start forward, start reverse and stop complete. Now we're just gonna finish up our selector switch. So now I'm gonna supply from the bottom of that normally closed contact. I'm going to supply the top of that normally closed contact on the R, so it's run high. I'm going to supply to run low, and then I'm gonna go back to run medium. So that's how I have to wire my run medium, because I don't have a third position on this selector switch. I only have an off position. I have 2 on positions and 1 off position. So I have to interlock the RM. If the switch is off, RM has to be interlocked with run low and run high. Okay, so now I've supplied my selector switch. So now I can just wire run low, run medium, and run high back to the drive. So we're going to do that now from those 3 outputs that you see available there. We're gonna supply run low, run medium, and run high back to the drive. So here are my 3 wires from the selector switch. So we've got run high as this one. The bottom one, as you can see, is run low, and the normally closed, which I have to use because I don't have a third contact or a third position on this selector switch. So I had to do a bit of interlocking here. I wire from the normally closed to run medium, and that is where it is run low, run medium, run high. Okay, now we're going to wire the lamp quickly, and yeah, then we should be finished. So now from the relay output of my drive, the normally open contact, I've wired a wire to the one side of my lamp, and now the last wire we're going to wire, I have to supply the other side of the lamp with 0 volt DC, which we're going to get from the SD, the 0 volt DC SD from the drive. Okay, so now I've taken from SD this purple wire, and I've wired it to the other side of the lamp so that I have 0 volt on that side. So if the drive trips, it will supply 24 through the relay back to the lamp, and the lamp will switch on. So okay, now we're gonna test if my circuit works and if the drive does it. This is just plain hard wiring, so yeah. But it just shows you don't always need a PLC. Maybe you've got something sitting far away from a little pump or something you want to drive, and yeah, you can do that through hard wiring. You don't need a PLC, but yeah, it's just a simple 3-wire stop-start. Well, they call it a 3-wire stop-start. Obviously there's not just 3 wires, but yeah, that's what they call it. So it's basically to do with just the stop and the 2 starts. I've now added on a selector switch for preset speeds, and I've added on a lamp, so just to make it a bit more interesting. But okay, we're going to switch on now, and then we're going to test. Okay, so let's see what this is gonna do. I've already set my preset speeds. Let me just show you. I'm gonna stay in the external mode, and that is run high, parameter 4. Parameter 5 is run medium, and parameter 6 is run low, which I've set to 40. So we're going to start up in run low because the selector switch is on the left hand side, run low. So we're going to start up and run low. So let's do that. Always remember to be in EXT mode, external mode, because you're getting your signals from externally. So let's check the direction of the motor. I think it's going to go counterclockwise actually when I press start forward. Yes, it does. So 40 Hertz. Okay, now we're going to, the selector switch is not too nice because I'm going to do this by one hand and make sure it makes good contact. There we go, it's on 45 because it's in the middle. Okay, and then I switch over to 50 hertz, and there it is on 50 hertz. Now, if I press the stop button, it should stop. Okay, everything is stopping. Now we're going to go reverse. Let's just check that motor. It should go clockwise now. Yes, and it should go to 50 hertz because I'm on one high. So now I can go back to, this is where it sometimes messes up because I can't get a nice contact here. Okay, there we go, switched over nicely. 25 hertz, then medium, and now we should go to low, 40 hertz. Okay, so that works all perfectly, and that's how easy it is. Now we can just press stop. Okay, and what will happen if I just go forward? Okay, let's go forward, and let's just switch it over to reverse. And it will stop and change direction. So yeah. Okay, now we're going to do something. I'm going to, let's see what the amps is. It's about 1.19 amps. So what we're quickly going to do is I'm going to stop it. Sorry, I'm going to stop it here. I almost wanted to stop it on the parameter unit. Okay, so we're going to go into PU mode. And let's go set the amps low so that we can see if our lamp works. Set that. It was 1.19, so I'm going to make that half. I'm going to make it let's make it 0.55 amps. So we just make a trip. We simulate a trip. So the motor is not really tripping because it's overloading, but we're just going to simulate the trip basically. Put it back in external. Okay, and let's start. Let's give it time to begin. Let's just check that amps. Drive should take a bit of time. Okay, there it tells me, here it comes. Okay, and my lamp works, yes. The drive is tripped and the lamp is on. So we just reset it, the lamp goes off, drive is ready, and let's do it in reverse, clockwise. Should start telling me, takes a few seconds. Okay, there it says yes, morning. Okay, you've tripped. Okay, my lamp works. Yes, both directions. So let's reset that, lamp off. Okay, and that's a simple 3-wire start stop without any PLC, just hardwired, and it all works nicely. You can have preset speeds, you can have a start forward, start reverse, and you can wire a trip lamp. So yeah, you can have a drive sitting remotely somewhere in the remote area, and you don't need to have a little PLC there. So yeah, hit the like, hit the subscribe, and I'll see you in the next one. Thank you for watching.